This video is an introduction to the law of cosines. Before I show you how to use the law of cosines, I want to show you where it comes from. Alright, so I've drawn in triangle ABC, where the measures of my angles are my capital letters A, B, and C, and then the measure for the opposite side from the angle is the corresponding lowercase letter. So my lowercase b side is across from my capital B angle. Same with my lowercase a side, it's across from my capital A angle. My lowercase c side is across from my capital C angle. This dashed line that I've drawn in right here represents the height of my triangle. Now this is an altitude, which means that it meets the base here at exactly a 90-degree angle. So I've essentially split this generic triangle that I've drawn into two right triangles, one of which has a base of x. I just use x here because it was convenient, and then this one is going to be a distance of a minus x, since the entire length of the base here is a, and we're excluding this bit x, so we get a minus x right here. Just a little note I want to make you aware of. My capital C's, I put this little tiny dash, or it might look like a little loop, right here at the top, and then my lowercase c's don't have that. So if you're not sure, that'll be your indicator to determine whether it's a capital C or a lowercase c. Now, since I've got two right triangles here, I can use the Pythagorean theorem on the right-hand triangle, so I'm going to do that up here where I've marked it R, and I can apply the Pythagorean theorem to my left-hand, I mixed those up. My right-hand triangle is the one over here, on the right, obviously. I'm going to write the Pythagorean theorem for that up here, and then for my left-hand triangle, I'm going to write my Pythagorean theorem down here. So, for my right-hand triangle, I get a minus x squared, because that's one leg, and then for my other leg, I have h squared, and then my hypotenuse is c. And then for my left-hand triangle, one leg is x, one leg is h, and my hypotenuse is b. Now, for this right-hand triangle, I'm going to expand this squared binomial, and I get a squared plus 2ax plus x squared plus h squared equals lowercase c squared. Now, if you'll take a moment to notice, down here for my left-hand triangle, I have that b squared equals x plus h squared, which means this x squared plus h squared up for my right-hand triangle can be replaced with b squared by substitution. So I can just substitute in b squared for my x squared plus h squared. Just like so. Now, the one last bit of relevant information that I need is that the cosine of my angle capital C equals my adjacent over my hypotenuse. So that's going to be x over b, which means that I can solve for x here, and I get that b times cosine of capital C equals x. So I can once again use substitution for this to replace this x in my right-hand triangle equation. And then I have a squared plus 2ab cosine of capital C plus b squared equals c squared. And this right here is our law of cosines. So this is a lowercase c squared, which is what I had right here, equals a squared plus b squared. So that's my a squared here and my b squared here, plus 2ab cosine of capital C, and that comes from this term right here. So this is my law of cosines. Now I want you to notice that in the special case that C here is 90 degrees, we have that cosine of 90 degrees equals 0. So this whole term right here goes to 0, and we're simply left with the Pythagorean theorem. So, this is consistent with what we already know about triangles. Now that we know the law of cosines, it might be useful to know when it's helpful to use the law of cosines. So, in order to apply the law of cosines, it's nice to know either all three sides. So if we have all three sides, we can figure out the value of our angle C. Or if we have the value of a side B and a side A and the value of the angle between them, so if we have our A, our B, and this angle C, then we can determine the remaining side. So it doesn't necessarily have to be labeled just this way. So any way we rotated our triangle or relabeled it, it's still going to work, which means any instance in which the given information is all three sides, or side angle side, meaning of course that we have a side, an angle, and then a side, all three consecutive, so the angle here is in between the sides that we know. These cases are going to be when the law of sines is helpful for us. So if you're given the measures of all three sides of your triangle, or the measures of two sides and the included angle, you should apply the law of cosines to find the missing information for your triangle.